Okay, so the first question is, suppose you integral a function from x0 minus h to x0 plus h, and we try to derive Simpson rules step by step. And the first step is we try to find a polynomial that interpolates the function f at 3 points. So x0 minus h and x0 plus h. So let me draw pictures. So the pictures look like this. So you have x0 here, x0 minus h, and x0 plus h. Okay, and the function is like this. And now we try to find a polynomial that goes through three points. Yeah. So this one at f, x0 minus h, and this one is f at x0, and this one is f x0 plus h. And because there's 3 points, so the polynomial should be a quadratic. So suppose you have a quadratic qx equal a0 plus a1 x minus x0 plus a2 x minus x0 square. Okay, and then we try to find a0, a1, a2 by the interpolation condition. So now if I put in q at x0 minus h, then I should have a0 plus a1. So this one is x0 minus h minus x0 plus a2 x0 minus h minus x0 square. And this one should equal f at x0 minus h. Yeah. So I simplify a little bit, so then I have a0 plus a1h. Yeah. So x0 minus, so this one actually should be minus. Okay. And then plus a2 x0 minus h, so h square equal f x0 minus h. Okay. And then, so this is the first point at x0 minus h. And at the second point, so q at x0. So then I have a0 here, and x0 minus x0, 0, x0 minus x0 equals 0, equal f at x0. Okay. And the last point is q at x0 plus h. Okay, and you put in, so you put x0 here again, then you have a0 plus, so now x0 minus h become x0 plus h. Yeah, so a1 x0 plus h minus x0 plus a2 x0 plus h minus x0 square, and this one should equal f at x0 plus h. And we simplify the x0, then you have a0 plus a1h plus a2h square equal f of x0 plus h. And you can see that we don't have to find a0 because a0 just equal f of x0. Okay. And now, so maybe I label this one is equation 1, and this one is equation 2. Then you will have, if I take number 2 minus number 1, so if I take number 2, equation number 2 minus number 1, then the a0 goes away, and a1h, so become 2a1h. Yeah, so 2a1h, and a2h square goes away, so it will become f x0 plus h minus f x0 minus h. Okay, and so I have a1, so a1 is just 1/2 or maybe 1/2h of f x0 plus h minus f x0 minus h. Okay, so I have a0 here, I have a1 here, and now I just substitute to find a2. So a2, so suppose I take number 1, then I have a2 will equal, so I put in maybe a2h square, yeah, I just put in, so this one a2h square, and then have a0, so a0 is just f x0, and then I have a1h, so I have minus h times a1 is 1/2h f x0 plus h minus f x0 minus h. Okay, so this is my a1, so a0 and a1, so this is a2, and on the right hand side just have f of x0 minus h. Okay, and I can simplify the last one, so I can simplify the h here, so I got, so maybe let me remove these pictures to get some more space. Then, so I have a0h square, sorry, a2h square, okay, equal f0 equal f of x0 minus h. Then I move this one to the left, so will be minus f x0, and this one become a plus, yeah, so this one move to the right, so become a plus 1/2 f x0 plus h minus f x0 minus h. Okay, and rearrange it one more time, then I have a2 will equal, so you divide it by 2h square, yeah, then you have, so this one is 1/2 of f x0 minus h minus 2f x0, yeah, because this one become f x0, yeah, and then plus 1/2, so 1/2 here, so f of x0 plus h, and so this one is a2, so you have three coefficients, so this one is a2, this one is a1, and this one is a0, and that completely specifies the polynomial that interpolates the function f at 3 points. Okay, so the coefficients are given in terms of the value of the function at the 3 points, x0 minus h, x0, and x0 plus h.